Good afternoon. I'm Christian Jones A. Puzon, an electrical engineering student. In this video presentation, we will tackle about linear programming simplex maximization method by George B. Danzig of Stanford University. And in this presentation, we will explore the core concept of linear programming and introduce you to the simplex maximization method and walk you through a step-by-step example to illustrate how it works and 3 problems I will give to you. Introduction. Linear programming is a mathematical optimization technique used to find the best outcome in mathematical model with linear relationship. And the simplex maximization method is one of the primary algorithms used to solve linear programming problems. And it starts with an initial feasible solution and it starts with an initial feasible solution and systematically moves towards the optimal solution by pivoting along the edge of the feasible region. Take note, linear programming is said to be in standard form if the constraints are modeled as equalities. Okay, in rules of the maximization method, in greater than symbol, if the constraint has a greater than symbol, we cannot transform it into an equation by immediately adding slack variables. Instead, we first convert a greater than symbol to less than by multiplying the inequality constraint by negative 1, then add a slack variable. For example, this as is projected here in the board. Okay. Here in problem number 1, we will use a simplex maximization method using greater than symbol. A company produces 2 types of products, A and B. Each unit of A requires 4 hours of labor and 2 hours of machine time, while each unit of B requires 8 hours of labor and 4 hours of machine time. The company has 6 hours of labor and 16 hours of machine time. Time available. Product A yields a profit of 5 peso per unit and product B yields a profit of 6 pesos per unit. In this problem, we ask how many units of each product should be produced to maximize profit. In step-by-step solving, in step 1, transfer the objective function into equation form in such way that all variables are written on the left hand of the equation, and transform the constraint into equation form by adding necessary slack variables to each of the given constraint needed to formulate a new object. Here, I will show the z is equals to 5x plus 6y is equals to 0. And our constraints will be 4x plus 2y is less than 6. And our constraint number 2 will be 8x plus 4y is greater than 16. And our x and y is greater than 0. And we will transform it into new object function. Our z equals 5x plus 6y is equals 0 to negative z plus 5x plus 6y plus 0 times slack variable 1 plus 0 slack variable 2 is equal to 0. And our constraint number 1 is 4x plus 2y plus slack variable 1 times 0 plus slack variable 2 is equals to 6. And our constraint number 2 is 8x plus 4y plus slack variable 1 plus 0 times slack variable 2 is equals to 16. And our constraint number 3 and 4 is as is. X is greater than 0 and y is greater than 0. For step 2, we plug in the numerical coefficient of the variables in the simplex W and compute the values for the Cj and Zj minus Zj row values. Remember that the Cj row will contain coefficient of the objective function while Cj column is the contribution to profit. Here, as is projected, we have the contribution to profit here, and the variable column, this is the entering value, the quantity column, and our constraint coefficient row, and our variable row and our objective function will be at the top. For step 3, to calculate the values for 0, you will have to get the sum of the products of the profit contribution in CJ column in each of the coefficient in the constraint. To compute for the Z minus ZJ row values, you subtract the CJ row values by the ZJ row values. Okay. Our ZJ is equals to quantity 0, x0, y0, and s1 in row. This will be 0 and s2 row will be 0.
Oh.
To calculate the values for 0, you will have to get the sum of the products of the profit contribution in CJ column in each of the coefficient in the constraint. ZJ equals to 0 times 6 plus 0 times 16, 0 times 4 plus 0 times 2, and 0 times 8 plus 0 times 4, and 0 times
Go.
To calculate the values for 0, you will have to get the sum of the products of the profit contribution in CJ column in each of the coefficient in the constraint. Okay. What is that? ZJ is equals to 0 times 6 plus 0 times 16, our quantity, and our x is 0 times 4 plus 0 times 8, and our y is 0 times 2 plus 0 times 4, and our slack variable 1, 0 times 1 plus 0 times 0, 0, and our slacks variable 2 is 0 plus times 0 plus 0 times 1 is equals to ZJ.
Go.
To calculate the values for 0, you will have to get the sum of the product of the profit. 0 times 1 plus 0 times 0, 0, and our slacks variable 2 is 0 plus times 0 plus 0 times 1 is equals to ZJ.
Go.
To calculate the values for 0, you will have to get the sum of the product of the profit contribution in CJ column in each of the coefficient in the construction. To calculate the ZJ, we need to 0 times 6 plus 0 times 16 and 0 times 4 plus 0 times 8 and 0 times 2 plus 0 times 4 and 0 times 1 plus 0 times 0 and 0 times 0 plus 0 times 1. And our CJ will be 0, 0, 0, 0, 0. Next.
Go.
To compute for the CJ and ZJ row values, you subtract the CJ row values by the ZJ row values. CJ minus ZJ. We have 5, 6, 0, 0, 0. And our ZJ is 0, 0, 0, 0. And we will get 5, 6, 0, 0, 0. Next one. And we need to input this in our Simplex W1. Here we have our ZJ 0, 0, 0, 0, 0. And our CJ minus ZJ is 5, 6, 0, 0. For step 3, since this is a maximization problem, scan for the positive coefficient in the CJ minus CJ row. The one with the most value in the CJ minus CJ row will determine the pivot column. The variable found at the top of the pivot column indicates the entering variable. Here we determine our most positive value is our 6. And step 4, compute for the test ratio by dividing the entries of the quantity column by the non-zero and negative entries of the pivot column. The associated row with the smallest positive ratio determines our pivot row, and the associated variable to the left of the pivot row will be leaving. Okay, balik. Here we have our we will gonna be test ratio. On our 6, we will need to divide our 6 to 2, and we will get 3. And our 16 will divide into 4, and we will get 4. Thus S1 leaves and Y enters. The pivot element is the entry intersect by the pivot column in the pivot row. Here the S1 leaves and our Y enters. For step 5, we want to convert the pivot element into 1. So, we divide each entry in the pivot row by the pivot element, then enter the result in the next tableau. Next one. Here, that's a
Go.
To compute for the new values for each remaining rows and columns, follow this formula. New row element is equals to entry in old row times minus associated element in the pivot row that is above or below the entry multiplied by the associated element found in the pivot column located left or right of the entry of the old row divided by the pivot element. In step 5, we need to 16 minus 6 times 3 divided by 2, we got 4. Subtraction?
Go.
To compute for the new values for each remaining rows and columns, follow this formula. New row element is equal to entry in old row minus associated element in the pivot row that is above or below the entry multiplied by the associated element found in the pivot column located left or right of the entry of the old row divided by the element. Here in step 5, 16 minus 6 times 3 divided by 2, we got 7. And 8 minus 4 times 3 divided by 2, we got 2. And 4 minus 2 times 3 divided by 2, we got 1. And 0 minus 1 times 3 over 2, we got 1/3. And 1 minus 0 times 3 divided by 2 is equals to 0. Next table, please. Here, we got our 7, 2, 0, negative 3 over 2. And 0. No? Asa dito?
Go.
Here in step 5, we need to 16 minus 6 times 3 over 2 is equals to 7. And 8 minus 4 times 3 over 2 is equal to 2. And 4 minus 2 times 3 over 2 is equals to 1. And 0 minus 1 times 3 divided by 2 is equals to negative 3. And 1 minus 0 times 3 and divided by 2 is equals to 1. As is shown in the table, we have our 7, 2, 0, and negative 3, 2, 3 over 2, and 1. For step 6, compute for the values for the ZJ and zj row value as in step 2. That's up. In step 6, compute for the values for the zj and cj row values as in step 2. We need to compute our zj is equals to 6 times 3 plus 0 times 3 and 6 times 2 plus 0 times 2 and 6 times 1 plus 0 times 1 and 6 times 0 I mean 1 half plus 0 times 1 and 0 times negative 3 over 2 and 6 times 0 plus 0 times 0. And our zj is equals to 18. 6 times 2 is 12. And 6. And our 6 times 1 half plus 0 times negative 3 over 2 is 3. And our 6 times 0 plus 0 times 0 will be 0. And for our zj values, we need to subtract our 6. We need to subtract our 5x to 12. And we will get negative 7. And our 6 to our 6 will be 0. And our 0 minus 3 is equals to negative 3. And our 0 will be 0. In the Simplex W number 2, here's our final input in the here is our final Simplex W2. And in step 7, if there is a positive entry in the cj minus cj row, return to step 3. The final solution has been off there if is no positive value in the zj row. But as you can see, there's no positive values here in our zj minus zj row. And as it said in the step 7, the final solution has been off there is no positive value in the cj row. In conclusion, 3 units of each should be produced to maximize the profit to 18 pesos, which is our answer to problem number 1. For problem number 2, a farmer has 15 acres of land and available to plant wheat and barley, and each acre of wheat requires 3 units of labor and 6 units of fertilizer, while each acre of barley requires 4 units of labor and 4 units of fertilizer. The farmer has 16 units of labor and 18 units of fertilizer available. Wheat can be Wheat can be sold for 160 per acre and barley can be sold for 150 per acre. In this problem number 2, it asks how many acres of each crop should be farmer plant to maximize revenue. In step 1, we need to transform our z is equals to 160 x plus 150 y is equals to 0. And our constraints will be 3x plus 6y is less than 15, and our constraint number 2 is 4x plus 4y is less than 16, and our x and y will be greater than 0. We need to transform this into new object function, and the z is equals to 160x plus 150y is equals to 0 will be negative z plus 160x plus 150y plus 0 times slack variable 1 plus 0 times slack variable 2 and is equals to 0. And our constraints number 1, 2, 3 will be 3x plus 6y plus 0 times slack variable 1 plus slack variable 2 is equals to 15, 4x plus 4y plus slack variable 1 plus 0 times slack variable 2 is equals to 16. And our x and y will be as is. X is greater than 0 and y is greater than 0. In step 2, we plug in the numerical coefficient of the variables on the simplex W and compute the values for the z, j, and zj row. To compute our zj, is equals to 0 times 15 plus 0 times 16, 0 times 3 plus 0 times 4, and 0 times 4 plus 0 times 4, and 0 times 1 plus 0 times 0, and 0 times 0 plus 0 times 1 will be, our zj is, as always, will be 0, 0, 0, 0, 0. To compute for the cj and minus cj row, it needed to be subtracted by the zj row. Cj minus cj row will be 160, 150, 0, 0, 0. And our zj is 0, 0, 0. And just bring down 160, 150, 0, 0, 0. In the simplex W1, it shows that the zj and minus cj row compute for the cj row values, you subtracted the zj row values, and we got 160, 150, 0, 0, 0. Here it shows the 160, 150, 0, and 0. For step 3, since this is a maximization method, we just need to find the most positive value. Next. Here, our positive value is 160, and our constraint coefficient row, it has 0, slack variable, 1 and 15, 3, 6, 1, 0. For step 4, compute for the test ratio. We need to compute for the test ratio of 160.
Ego.
To test for the test ratio by dividing the entries of the quantity column by the non-zero and non-negative. Here we have R is equals to 15 divided by 3 is equals to 5. And our R is equals to 16 divided by 4 is equals to 4. And ibalik ko natin. Here we have our smallest positive value, and we need to divide it to the constraint coefficient row. Here we have 15, 3, 6, 1, 0. And we need to divide to, or times 2, 1/3. Here we get 5, 1, 2, 1/3, and 0. This is our new slacks variable y. Thus, S1 leaves and y enters, the pivot element is the entry intersected by the pivot column in the pivot row. Here, we have our 5, 1, 2, and 1/3, and 0. For step 5, we want to convert our element into 1. So, again, we need to minus our
Trigo.
For step 5, we need to 16 minus 2/5 and divided by 3. 15 times 5 divided by 3 is equals to 9. And our 4 minus 2 times 5/3 is equals to 7/3. And our 4 minus 2 times 5 over 3. I mean, 1 times 5 over 3 is equals to 2 over 3. And goes up.
Go.
In step 5, 16 minus 15 times 3 over 3 is equals to 9. And 4 minus 2 over 5 over 3 is equals to 7 over 3 and half. And 4 minus 1 times 5 over 3 is equals to 230. And our 0 minus 1 times 5 over 3 is equals to negative 530. And our 1 times 0, our minus 0 times 5 over 3 is 1. As it shows us, this solves on the question of the problem number 2. For problem number 3, a furniture manufacturer produces tables and chairs. Each table requires 3 hours of carpentry work and 3 hours of finishing, while each chairs requires 6 hours of carpentry work and 4 hours of finishing. The manufacturers has 12 hours of carpentry work and 20 hours of finishing available. A table yields a profit of 5,200 and a chair yields a profit of 6,100. Problem number 3 asks how many tables and chairs should be produced to maximize profit. Again, in step 1, we need to transfer our Z1. Z is equals to 5,200 x plus 6,100 y is equals to 0. And constraints will be
Go.
in step 1, we have Z is equals to 5,200 x plus 6,100 y is equals to 0, and our constraint will be 3x plus 3y is less than
30.
12, and 6x plus 4y is less than 20, and our x and y will be greater than 0, and we need this to transfer in the new objective function. Our z is equals to 5,200x and plus 6,100y will be negative z plus 5,200x plus 6,100y plus 0 times slash variable 1 plus 0 slash variable 2 is equals to 0, and constraints will be 3x plus 3y plus 0 times slash variable 1 plus slash variable 2 is equals to 12, and our slash variable constraints number 2 will be 6x plus 4y plus slash variable 1 plus 0 times slash variable 2 is equals to 20, and our x and y will be as is. X is greater than 0, y is greater than 0. For step 2, we plug in and input this into the Simplex W1. Remember that the CJ row will contain the coefficient of the objective function, while CJ column is the contribution to profit. As it's shown in the Simplex W1. Next, please. We have our constraint coefficient row 12, 3, 3, 1, 0 and 26, 4, 0, 1. To compute for the CJ and CJ minus CJ, we will follow this step number 3. Step 2. CJ minus CJ will be is equals to 0, 0, 0, 0, 0, and 5,200, 6,100, and 0, 0. Here, we have our zj and cj minus cj here in Simplex W1. For step 3, since this is a maximization problem, we need to find our most positive value. Here we have our most positive value and our constraint row will be marked. For step 4, compute for the test ratio. Again, cut.
Go.
For step 4, we need to test the ratio by dividing the entries of the quantity column. So we have 12 divided by 3 is equals to 4 and 20 divided by 4 is equals to 5. And the associated row with the smallest positive ratio determines our pivot row, and the associated variable to the left of the pivot row will be leaving variable. Here we have 1/3 times 12, 3, 3, 1, and 0. 1/3 times 12 is equals to 6, 1, 1, 1/3, and 0. Okay, in our thus
Go.
thus S1 leaves and Y enters, the pivot element is the entry intersect by the pivot column in the pivot row. As is shown in the table, we have our Simplex W number 2. Here we have our
Go.
For step 4, we need to test the ratio. We have R is equals to 12 divided by 3 is equals to 4. Our R is equals to 20 divided by 4 is equals to 5. And the associated row with the smallest positive ratio determines our pivot row, and the associated variable to the left of the pivot row will be leaving variable. We have 1/3 times 12 times 3 times 3 times 1 and 0 will be 4, 1, 1, 1/3, and 0. On our simplex table number 2, we need this to input on our constraint coefficient row. We have 4, 1, 1, 1/3, and 0. For step 5, we want to convert the pivot element, so we divide each entry row by the pivot element. Then enter the results in the next APU.
Go.
For step 5, we need to follow this formula. 20 in the tree. This 20 is in the problem tree. 20 minus 12 times 4 minus 3 is equals to 4. And 6 minus 3 times 4 minus 3 will be 2, and 4 times 3 times 4 over 3 will be 0, because 3 times 4 is equals to 12 divided by 3, 6. But we need to follow this formula. Here we have 20 minus 12 times 4 divided by 3 is equals to 4. And 6 minus 3 times 4 divided by 3 is equals to 2. And 4 times 3, minus 3 times 4 divided by 3 is equals to 0. And 0 minus 1 times 4 divided by 3 is equals to negative 4 over 3. And our 1 times 0 times 4 divided by 3 will be 1. This is our new 420.
Go.
For the remaining row, we need to use this formula. 20 minus 12 times 4 over 3 is equals to 4. 6 times 3 times 6 minus 3 times 4 over 3 is equals to 2, and 4 is equals to 1 times 4, 3 is equals to 0, and 0 minus 1 times 4 over 3 is 1/4, negative 1/4, and 1 minus 0 times 4 times 3 will be 1. In the Simplex W2, we need to input this. Here we have the 4, 2, 0, negative 1/4, and 0. For the ZJ and minus CJ minus CJ row, for step 6, compute the value for the ZJ and CJ row value as in step 2. Again, we need to find our ZJ. It's equals to 6,100 times 4 plus 0 times 4, and 6,100 times 1 plus 0 times 4, and 6,100 times 1 plus 0 times 0, and 6,100 times 1/3 plus 0 times 1, and 6,000, lastly 6,100 times 0 plus 0 times 0. Our CJ will be 24,000 and 6,100. Again, 6,100 times 6,000 times 1 will be 6,100, and 6,100 times 1/3 will be 6,000 over 3, and 6,100 times 0 will be 0. Here we have our ZJ row. To compute the CJ minus CJ, we need to subtract our ZJ value to the objective function coefficient. Here, in the CJ row, minus CJ will be 6,100 minus 5,100 will be negative 100, and 6,100 minus 6,100 will be 0, and 0 times 6,100 over 3 will be 6,000, negative 6,000 over 3, and 0 minus 0 will be 0. Here, as is shown, we have our negative 900, 0, 6,100, and 0. As in step 7, if we have no positive value, the final solution has been there. If there is no positive value in the CJ and ZJ row. To the conclusion, 4 tables and chairs to maximize the profit PHP or 24,000 pesos for our problem number 3. I'm Christian Jones A. Puzon. Now let's dive into the fascinating world of linear programming and the Simplex Maximization Method. Thank you.